Okay, so this is the session number 7, and today we are going to see about interpolation. So, agenda for the today's session is we are going to see the formula of Newton's forward difference interpolation, which can be used for interpolating the values. Okay, that means we can find the function values for the given value of x. And another thing that we have here is we are going to find approximate polynomial or a polynomial which fits that data. Okay, a polynomial which fits that data. Now, before we start, let we see we already seen in the finite differences also that suppose we are given this set of points, say values of x and y we are given. Let I change the ink here. So the values of x and the values of y we are given. Say x0, y0, x1, y1, x2, y2, and say x3, y3. Only these values we are given. Suppose we are given these values of x and y. How many pairs of xy were given?
5.
Five. Not five. So x and y is the heading. There are 4 pairs. Correct. There are 4 pairs. Okay. So x0 y0 to x3 y3, 4 pairs of x and y were given. So can you tell me which degree polynomial will fit this data? What is a
3.
3? There is correct answer. Yes, we are already seen in the finite differences that for the n when we are given n pairs of x and y, the polynomial of n minus 1 will fit that data there. Correct. Now, what is the interpolation first? The interpolation is a method. Actually, the interpolation is a method in which we are going to find the missing value of x, sorry, missing value of y for the given value of x. But what is that missing value? Actually, we are given the values of x from x0 to x3. So indirectly, the values of x we are available the values of x are available in the interval x0 to x3, and suppose in between x0 and x1 there is some point and we have to find the value of y for that value of x. That is an interpolation. There is another thing known as extrapolation, but that extrapolation is not part of our syllabus. So in extrapolation we are finding the value of y outside that interval x0 to x3 there. Okay, so in simple words, just we are going to predict the value of y. We are going to predict, or we are going to find approximate value of y for the given value of x with the help of interpolation. That is our aim here. So the same, just a minute. So if you observe here, we are given the set of values of x0, y0 to x and yn. So we are given suppose n pairs of xy. So we are going to predict the value of y for the given value of x. That is the purpose of interpolation here. Clear? Any doubt?
No, sir.
Okay, good. So come to the formula here. So the formula is again without derivation. We are not going to derive it. The formula f of a plus xh here, f of a plus xh is equal to f of a plus x delta fa plus x into x minus 1 upon 2 factorial delta square fa plus so on. That formula is known as a Newton's Gregory forward interpolation formula. Okay, this is forward difference interpolation formula. Can you see these terms and can you tell me these are similar to some known things to you? Yes. What are
Sir,
these?
x factorial.
It is not x factor, x 2
Sir,
factor.
x square factorial.
X square factorial? No.
Sir, XC2.
Correct. It is a combinatorics. Correct. So actually, this is similar to the combinator. It is XC2, XC3, and so on. So it is very simple to remember. It's not so difficult. The formula is so simple here. Value of f of a plus xh is given as f of a plus x delta fa plus xc2 delta square fa plus xc3 delta cube fa and so on. That way. Now you'll observe this formula we are going to use to find the missing values of the function. So indirectly we have to find the value of a function at this a plus xh. Whenever we have to find out the value of a function at a plus xh, generally we select closest upper value as a in the table. Now what is a table? That table means that initially we written there. Initially we written that say x0, x1, x2, x3. Remember, in particular, let I write one values, few values here, so that you will get same meaning of this. Suppose x0 is 10, x1 is 20, x2 is a 30, and x3 is a 40. The first important thing that you will notice here, and that we already seen in finite differences also, the values of xi should be equally spaced. Okay, the difference between two successive values of x is known as a class interval. So what is the value of class interval here?
Sir, 10.
10, correct. So that is denoted by h. H is a class interval, and that is a 10 here. Okay. Now, if we are interested to find the value of fx, actually, few fx values will be given here, say 1, 0, 0.8, 5, something like that. These values x and fx will be given to us. But instead of these values of x, suppose our interest is to find the value of fx, say at x equal to 15. We are interested, what is the value of fx? What is the fx for x equal to 15? Then that
Sir,
process, yes,
0.5.
yes, Chirag.
Sir, would it be 0.5?
Okay, so your guess is a zero point 0.5. How you said that is a zero point 0.5? Because x is the average, then so fx should be average there, is it?
Yes, sir.
But that is not always there. It need not. We don't know that function fx. We don't know that function fx. This fx may be a standard function also, say log x. It can be a standard function, or it may be a combination of that standard functions. So these functions are completely unknown to us, and we are interested to predict that functional value at that x equal to 15 there. Okay. Then the this Newton's forward interpolation formula, to use that formula, generally we select the closest upper value of x as a there. So this value will taken as a plus xh. So a plus xh should be 15. Where we have to find it? Our aim is to get f of 15. So this bracket a plus xh is 15 only. So what should be a now? Closest upper value, and that is obviously, see, 15 lies between 10 and 20. So upper value is a 10. So generally a is selected as a closest upper value, and that is a 10. So a should be 10 here. And now with these values, obviously we can find the value of x because a is known to us, h is given. So x can be calculated, and we can replace in the Newton's Gregory forward interpolation formula, and we get the required value there. But one more important thing you'll observe, once we select that a, we require all the differences. We require all the differences related to that a, that is known as a leading differences. These are the leading differences. So you'll observe the terms which are used in the formula, that are f of a, delta f of a, delta square f of a, delta cube f of a. That means we require all higher order differences of at x equal to a. So all the higher order differences values we require from a, and all these values we can obviously get by a finite difference table that we learned in the previous session. Already in the last session, we seen how to get that difference table here. Okay, so come to the example, it becomes more and more clear. Okay, if you have any doubts after that example, yes, we'll discuss about the method here. So, okay, one more important thing I forgot here, that is, you will observe here is a note is written that this forward interpolation formula is mainly used only when we have to find the value of a function at the beginning of the data. Beginning of the data means, just we seen, we are given the data from say 10 to 40, and we are interested to find the value of fx at x equal to 15. Anyone have that guess why this is the condition, why this is a restriction that we have? Any guess? This x and y are given. Say x is given 10, 20, 30, and 40, and that fx is also given here. Okay, so y equal to fx there. So this will be given, and we are using this forward interpolation formula mainly whenever we have to predict the value of fx, when we have to predict at near the beginning of the data, means say between 10 to 20 or 20 to 30 only. But if you have to predict between 30 to 40, this Newton's forward interpolation formula fails there. It will not give a good approximation. It gives us a very bad approximation, which is definitely too away from the actual value. What is the reason? What may be the reason there? Can you have a guess?
Don't know.
Don't know. Okay, no issue. Good. See, the problem is actually this. If you see the formula involves this higher order differences up to delta cube and so on there. When we uh, when we calculate forward differences and when we select a as a 10, we get a large number of that leading differences there. Means we may get up to delta 5, delta 6 also. That means when we increase the number of terms, if the number of terms are more in the formula, the accuracy will be the more there. But if we take a last value, for the last value, there is no forward difference exist. There is no forward difference exist means, or say 30. If 30 is there, probably there is only one forward difference exist. So in that case, only you will get f of 30 and delta f of 30 probably. Okay. So delta f of 30, and that gives only two terms. When we taken a less number of terms, the accuracy will not be more. We'll discuss all these things with example, then it becomes more clear. But right now, just remember forward interpolation formula mainly used to predict the value of a function at the beginning of the data there. Okay. So come to the example here. Okay, so I hope all you can read the question. See the question first. We are given the table of distances in nautical miles of the visible horizon for the given heights in feet above the Earth's surface. So sometimes the question is a descriptive like this. In some cases, just the values of x and y are given because main interest is our to get that table values x and y and to predict the functional value. That is our main interest here. So what should be step one? Yes, to predict. Just we discussed the process. What should the step one that we should do it here? Any guess?
So we have to find the h.
Okay, yes, we should find out the value of h. We should find out a plus xh. We should write what should be the yes a. Okay, that all things we should decide. So let me focus only on first bit because in the exam, remember the question will come only for one part. This is just for practice. I taken here that find the value of fx when x is 120 and find the value of fx when x is 200. It is just for practice. But in the exam, if you see the old question papers, you will find only at one point you have to evaluate it. So can anyone tell me what should be a plus xh first?
So 120.
120.
Yes, 120 itself. Correct. So where we have to find the function value, that should be a plus xh. So we can start with like this. Let a plus xh is 120. Now what is the a and what is h?
So
One by
a
one.
is 100, h is
300
50.
and H is
Very good.
50.
Very good. Nice. So why a is 100? Because it is a closest upper value. So if you observe 120, 120 lies between 100 and 150. Okay, and closest upper value is 100 there. So a should be 100 and h is already you said that is a 50. Good. So h is the difference between two successive values of x there. That's correct. So can you tell me now x? What should be x here? Here is a, here is h. A and h is known. Just replace all these values here and calculate 120 minus 100 upon 50. No calculator required. It is so simple, na?
So 0.4.
zero point 0.4. That's one. So here is the first part. That first part you decided, and now we know that formula. We know the formula. What is the formula of Newton's forward interpolation? F of a plus xh is equal to f of a plus x delta f of a plus I can write xc2 also, xc2 delta square f of a plus xc3 delta cube f of a, and so on. Okay, this is xc3 is there. So this is the formula of a Newton's forward interpolation. What is the missing thing that we yet not obtained that from this formula? That which values we should compute here before we start this calculation? Yes, quick. Hello. Is my question clear? Here is a formula for f of a plus xh. These values are available, but few things are unknown to us. Which things are not known yet here?
The
Yes,
function is not known.
function is not known. That is obviously, that is always there in interpolation. If we know the function, we can directly calculate the value. Okay. Uh, the correct answer is few of you already given that is delta fa, delta square fa, delta cube fa. These values are unknown to us, and these values are known as a leading differences, and these leading differences we can calculate it by a finite difference table. So we should prepare a forward difference table. Okay, so already we discussed about how to make the difference table, so I will not go in that. I will directly show you the table. So here is a table, you will observe. So the table is on the screen. You will observe the first column is taken as x, these values of x. You will observe these are the values of x here, which we are given here as it is. Next is y. Y is nothing but this fx. Okay, this x and fx are given. Then delta fx is calculated. So can anyone tell me how 2.40 came here?
So 13.03 minus 10.6.
Correct. So this is f of a plus xh minus fx. That is a formula for delta fx, and that we use throughout this table. And right now you will observe up to sixth order difference we received here for this, because this we are given probably the 7 pairs. So when the 7 pairs are there, maximum 6 differences can exist there. And for this 7 pair, we already know the sixth degree polynomial is going to approximate this data. Okay, approximate this data means we can get a polynomial which best fit this data is a sixth degree polynomial here. That's one. Now yes, obviously this a is 100. We've taken a as 100. This is f of a, this is delta f of a, delta square f of a, delta cube f of a, and so on. Okay, so only the thing that left here, we have to replace all these values in the formula and simplify. So let I write it here so you will get it. So let me replace each values then. So we want f of 120. Therefore, f of 120 will become, what is f of a? What is f of a?
10.63.
Correct. What is a x? X is zero point 0.4. Okay. Delta f of a? Yes.
2.40.
2.4.
2.40. Correct. xc2 now. That is x into x minus 1 upon 2. So what is x is a 0.4. What is x minus 1?
Minus 0.6.
Minus 0.6 upon 2 factorial. 2 factorial is just 2. And delta square f of a will be minus 0.39. Minus sign, minus 0.39. So this is the third term. Now fourth term, I will write it here. X into x minus 1 into x minus 2 upon 3 factorial. What is 3 factorial?
6.
6. Correct. And delta cube is a 0.15. Okay, just this is 0.15 here. Okay, so just correct it. So that about third term, no sorry, fourth term. But how many terms we can write it? Fifth, sixth, and seventh. So it can be written up to seventh term. But I will tell you in the exam also. In the exam also, generally, if you do the calculation up to the cubic difference, then also you will get a very good accurate answer, because whatever the higher order differences are there, they may affect the higher decimal places. Okay, higher decimal places, and generally we are expected to get the answer up to 3 to 4 decimal places in the final exam. So it is enough to take up to the cubic difference. Why we are considering up to the cubic difference? Why not the higher order? There are two reasons. Okay, when we first tell me when we can ignore the higher order difference. Yes, there is plus some terms there, but we can ignore it. Or what should be the reason? Can you think what should be the reason to ignore the reason or to ignore the terms? See, there will be one more term now after this. Say this is a xc3 xc4 xc4 delta 4 fa plus xc5 delta 5 fa plus xc6 delta 6 fa. So that terms are not written. What is the reason I ignored that term? The reason is they are
Their
negligible.
values will be small.
Yes,
Because the
correct.
LFs, the
Very good.
LFs
Very good.
cube are very small.
Yeah, that is correct answers there. So first thing you will observe this delta 4 fa, delta 5 fa, delta 6 fa, they are small number. First they are small number. And their coefficient, what is the coefficient? Coefficient is like say xc4. When xc4 is there, what is the denominator? Denominator is 4 factorial. So you are dividing by a large number, that is you are dividing by 24 there, and you are multiplying by a small numbers. So that is a very small number, and that will not affect generally the first 3-4 decimals. So we can ignore it. Okay, we can ignore it. But there is no thumb rule. There is no thumb rule that always you have to stop it with the delta cube only. The reason is suppose this delta 4 fa, suppose this delta 4 fa, this value is coming as a 10. Okay, instead of minus 0.07 it is a 10. Suppose this value is a 15, so it is better you should consider that calculation also. So you have to that observation is very important, whether these values are really small. If they are small, yes, you can ignore it. You can ignore it. It will definitely not affect to your answer. Okay, right now. But suppose that higher order differences are larger there, that time you should do a calculation. Okay, I already told there is no thumb rule to stop the calculation. That up to this term only you have to do that calculation. You have to decide on the numerical only. Okay, on particular numerical with table you have to take your decisions there up to which term you should take that calculation. But in general I observed that whatever the examples we have in our syllabus, in majority of the cases the calculation is done up to delta cube only. Okay, up to delta cube only. So higher order generally they are coming negligible there. Okay, so do that calculation. Can you do this calculation up to delta cube on calculator and check what should be the answer? Yes, anyone completed? Is there anyone who done that calculation? Yes. I'm asking to do this calculation on calculator 10.63 plus zero point 0.4 into 2.4 plus so on there. Okay, do this calculation. Yes, Anik is there. Anik,
Yes, sir, I'm doing, sir.
so you are doing. Okay. So let me see who will do the first.
Sir, 11.646.
11.646. Okay, good, Millie. Thank you.
It's
Okay,
11.6464.
646. Okay, good. So you'll observe what happened here now. The answer I written, or answer given in the textbook, answer given in the textbook is 11.649, and all of you are getting the answer 11.646 there. You will see it will just affected the third decimal there. It may be because we consider the three terms up to delta cube. It may if you consider one more term delta 4, you get correct up to third decimal also there. Okay, so even though if you write this answer in the final exam, you are getting the full marks there, so you should not worry. So you can do the calculation because at the end these methods are for prediction purpose, and after prediction we are going to get approximate value of a function, not exact value. Remember, there is a difference between the exact and approximate value. So exact value may be the 12 also, maybe the 12 also, but but generally it is not two away like this. So exact value right now we are getting 11.646. So this is approximate value. So exact value may be 11.6 only, like that. So there is very small minor difference in actual and approximate value. These methods are more accurate, so they are used for interpolation purpose. Okay. Any doubt? Any doubt?
No, sir.
Okay, good.
No, sir.
So we'll move to the second part of the question. The second part is we have to find out the functional value at 218. So quick, I want first a plus xh for a second part. What should be a plus xh?
218.
Yes, 218 itself, correct. So what should be a now?
200.
200.
Okay, that's a good answer here. Just above 218 because it's closest upper value 218 comes between 200 and 250. So a should be 200, correct. H
50.
50, good. And what should be x then? You have to do the calculation, small calculation. What should be x?
0.36.
0.36. Yeah, good, correct. Okay, good. Someone is on the chat. Yes. Okay, Chira, 0.36, correct. So 0.36 is a correct value of x. Now I want forward differences. What should be f of a, delta f of a, delta square f of a? Yes. What is f of a first for this question?
1.77.
1 point.
7.
I'm asking f of a. I'm not asking delta f of a. Start with f of a.
So 13.03.
103.
No, it is not 13.03.
15.04.
15.04 is f of a. This is a. A is a 200. So f of a should be 15.04. Delta f of a.
1.77.
Yes, now it is
1.77.
1.77. This is delta square, this is a delta cube, and this is delta 4. Again, you will observe this delta cube and delta 4 are very small. Okay, you can ignore delta cube, delta 4, or you can do the calculation at least up to delta cube. You will get 15.7 as answer. Can you do this calculation your own?
Yes, sir.
Okay, so try it. 15.7 is the actual answer given in the textbook. So if you do the calculation up to delta square and if you do the calculation up to delta cube, you can cross check what is the difference in the answer so that you will come to know when to ignore. And okay, so that is comes by practice only. When you practice, you will definitely understand this term is very, very small and we can ignore it. Okay, it will not affect in the addition there. Okay, so come to the second example. So second question is find y of 1.85. Find y of 1.85 provided the functional values are given here. The table is given. So can you tell me what is the uh, what is the first step? You will start here.
A plus
The
x
final
is
value
equal
of
to
A and
A
1.85.
plus xh is 1.85. Good. Then a.
A is equal to 1.8.
1.8.
Okay. Good. Next.
H is equal to 0.1.
0.1.
Nice. Next. X. X you should calculate then. Is it? And then the
Yes, sir.
difference table. Let I show you a solution here. This is the difference table first that you have to prepare. Okay. Remember last session also we done these difference tables there to get a missing values from the table. Okay, that time the missing values are from the table only. That like for 2 there is a missing value and for that we prepared the table and we calculated it. But I will tell you, you should take a caution while doing these calculations. If you do one silly mistake on calculate, these are simple subtractions, but like 0.637 minus 0.575 you are writing here, you missed suppose 0 or you written wrong subtraction, one wrong subtraction, entire calculation will miss table will become wrong and your answer will also come wrong and you will get you will not get full marks definitely there. So you should be very focused while doing the calculation of this when you write this table there. Okay, so that about the table first, where you already told me about a should be 1.8, a plus x is 1.85, x is a zero point 0.5 there. Okay, so this is by forward interpolation formula. I'm written directly the answer here. Don't forget to write a formula in the exam. You should start with the formula. So by Newton's forward interpolation formula, first write a formula. F of a plus xh is f of a plus x delta f of a plus x into x minus 1 upon 2 factorial delta square f of a and so on. First write a formula always and then do a calculation. This calculation you have to do it on calculator and should get the answer as a 6.359. Any doubt here? Any
No,
doubt?
sir.
No doubt.
No, sir, no doubt.
So come to the third question here then. Now tell me one important difference in this question and the previous two. What is the difference you observed? What is the difference in previous two examples and this example?
Trigonometric term.
No, that is not a difference. Okay, here is sign is there. Okay, that is okay. But the most important difference is here is in previous two question, the function fx is completely unknown to us. Right now, for known function, we are calculating it. We have to calculate sine of 48. Okay, that you can directly calculate on calculator also. Use a calculator, press sine and 48, you get answer. So this is an example where answer is already with you. This answer is already with you. But I will tell you that many students blindly do the calculation and they don't know what they are calculating. Means they are not focused there while doing calculation, and at the end they prepare the difference table, use forward interpolation and get sine 48 as 1.7 there. Okay, and they highlight it. Is it possible that sine 48 come 1.7?
No, sir.
No.
No, sir.
Yes, obviously it is not possible. The reason is obviously sine is a bounded function between -1 to 1. Okay, and so you should know. You should be more, alert when you are writing, when you are doing this calculation, because you are calculating, you are predicting the value for known function only, So you have the answer with you. It should come nearer to that. Okay. So this is a question where x is like 45, 50, 55 and 60, and fx is the right hand side values. Okay. So step number one, we should prepare the difference table. So here is the difference table. This is the x values. These are fx values, and forward difference table is prepared. So obviously a plus xh is 48, where a should be the closest upper value, which is the 45. Okay, and we use it for calculation there. And you'll observe this a plus xh is 48, a is 45, h is a 5, x is zero point 0.6, and by Newton's forward interpolation we get this as answer. Now you can cross check this answer on calculator. When you press on calculator sine 48, whether you are getting the near to the same answer there. If you getting the near to the same, then you are correct. Otherwise you made some mistake then in table there. Okay, that. Now, at the beginning, I told the important note is there for Newton's interpolation, that this interpolation we use to predict the value of fx at the beginning of the table. So this 48 lies between 45 and 50, which is near the beginning of the table. We not use this forward interpolation for near the end. The reason is, suppose we have to find out sine, say sine 57. Suppose sine of sine of 57 we have to calculate, and that 57 lies between 55 and 60. So then we have f of a here, we have delta f of a. What happens? We get f of a, this f of a as 0.8192 plus x into this value, delta f of a. And if you calculate this value and you check on calculator that actual value and the predicted value, there will be a difference now. The reason is only one difference we used, or only one difference we use for approximation purpose. So whenever there are more number of differences, more number of higher order differences, the accuracy is automatically increases there. Okay, actually in this case this delta cube also you can ignore. This is a too small number, it is 0.0007. So if you use only up to delta square, then also probably you get this answer. Okay, this answer. If you ignore this last term, because last term if you do the calculation on calculator, it is already a very small number there. You can cross check. So even though you ignore this term, then also you get good answer there. So the reason is that only that generally we use forward interpolation to predict the value of a function at the beginning of the table, at the beginning values of the table. Okay, that is the reason there. Any doubt up to here?
No, sir.
No, sir.
Okay, come
No,
to
sir.
the okay, then come to the last type of the question. Okay, there is one more variation in the question that we have in forward interpolation. and that variation is here. We have to find out interpolating polynomial. The question is find interpolating polynomial for these values of x, for these values of the data, and hence find the functional value at a 0.5. Can you tell me the values of x first? What are the x here? X takes the values
0, 1, 2.
0, 1, 2, 3, and fx is 1, 0, 1, 10. Correct. Can you tell me which degree polynomial will get as answer here? What is the degree of polynomial we should have as a final answer?
Sir, 3.
3.
Very good. That's a correct answer. Good. Why the 3? Because you'll observe there are 4 pairs of x and y we are given. So whenever n pairs were given, the data will be approximated by a polynomial of degree n minus 1. Okay. So here we get a polynomial of degree n minus 1 there. So that is a degree 3 here. So step number 1, we will prepare a forward difference table. You will observe the values of x is written here, then values of y. First order, second order, third order differences are calculated. So whenever the initial value is a 0, generally that type of the questions are asked in the exam for calculating interpolating polynomial, because that time it is a simple to get fx. But I will tell you, it is not a compulsion that initial value should be 0. In this case, we are taking a as a 0, and obviously h is, what is h here?
1.
1. So f of a plus xh becomes just fx, which we want actually. Okay, because in f of a plus xh, a is a 0, h is a 1. So it directly turns to our required thing, that is fx. And when we substitute all these differences there in that Newton's forward interpolation, this is f of a plus xh, which results to fx only. So this is f of a is 1, plus x into delta fa is a minus 1, plus x into x minus 1 upon 2 factor delta square fa, which is 2, and here is xc3 delta cube fa. You have to take term by term multiplication, simplify, we got a cubic polynomial. This is the cubic polynomial which we got here to approximate these values of x and y there. You can cross check also. Let me replace x by 0 here. What is f of 0 from this expression? F of 0 is 1. You will get it here. Replace x by 1 in this polynomial. So 1 minus 2 plus 1, you get a 0. F of 2, you should get as a 1. F of 3, you will get it as a 10. So obviously, this data will definitely satisfy these values of x and y. So we got a cubic polynomial because of 4 pairs of x and y are given. There is one more part in the question. We have to find out, hence find the value of f of 0.5. How to get it now?
Now we have equation, we can put on
Yes,
in the
directly.
equation.
Good. So there is no need to use interpolation again. So directly replace x by 0.5 there. F of 0.5 will be that 0.5 cube minus 2 into 0.5 square plus 1. And do this calculation on calculator, you will have the answer there. Okay. Any doubt here?
No, sir.
Okay.
No, sir, no doubt.
Okay. So that about our Newton's forward interpolation. So the two things we completed today. First of all, we seen the Newton's forward interpolation formula without derivation, because derivation is not part of our syllabus. Those who are interested, yes, they can see the derivation of the formula that is in our textbook there, B.S. Grewal.
So I
Yes,
had a doubt in
yes.
assignment 3.
Okay, we'll discuss. Just 1 minute. I'll finish it and we'll discuss the doubts. Sure. Okay. That is one thing. We discussed, we seen the formula, and then the first thing that we seen here, that this forward interpolation formula is used for prediction purpose. We are used for interpolating the value of function, that is a prediction of the function value at the given x. And lastly, yes, interpolation formula can be used to get the interpolating polynomial also. So that are the things that we completed today. Next session, yes, obviously we are going to continue interpolation, where you will learn the Newton's backward interpolation, and lastly we have Lagrange's interpolation. So that are the things we have in our interpolation topic. Okay, so